What is an organic compound? Most of the definitions of organic compounds look at whether or not the molecule is carbon-based. So if you want to know whether or not something would be considered an organic compound, we talk about it containing carbon. Now, it doesn't have to just contain carbon, right? If we're talking about molecules and compounds, they're going to be made up of multiple elements, right? So if that's the case, then we've got to look at having many different types of elements that are going to make these up. We've talked about carbon before. We've talked about the idea that carbon wants to share typically electrons with 4 different friends, or filling that outer shell of its electron cloud with 4 additional electrons. So those 4 bond points are because of those 4 electrons on the outside of carbon. Fine. When we draw these, you can draw them however you like, whatever makes sense to you as far as formulas, the ball and stick model, whatever works for you. I'm not so concerned about that. What I'm interested in is, all right, let's take some carbons and stick some stuff on it, because I need to make different molecules, different structures that are going to do different things for me. So hydrocarbons, it probably doesn't surprise you, are made up of carbon and hydrogen. So methane would be one that we see a lot, CH4, right? So carbon and 4 hydrogens. We can also build on to that, right? We build these carbon chains, and we build what we call carbon skeletons, which are simply a chain of carbon atoms. And they come in all different forms. Again, I'm not so concerned about you memorizing all of these different forms. They come branched and unbranched, fine. I'm not concerned about that. They can come in rings. They can come in double bonded structures. They can come in rings with double bonds. All of these sorts of biochemical processes. But what I'm really interested in is, what is it about this particular design that allows my macromolecule to function as I need it to? So we're often going to take these basic carbon skeletons and add things to them known as functional groups. And these functional groups are going to be some of the most important and unique characteristics associated with our macromolecules. So you'll see this when we start showing you macromolecule structures, that you start with a basic carbon skeleton, and it's essentially a building game of Legos. We continue to add things onto this until the structure is able to perform the function that we need. So functional groups allow a molecule to function the way it does. Now, some of them are going to be hydrophilic or water-loving. Some will be hydrophobic or water-hating, right? So these functional groups actually come in a variety of forms, but there are 5 big ones that you should be at least vaguely familiar with. Hydroxyl groups we've actually talked about before. We talked about hydroxyls when we talked about pH. So that's where you heard that term before with me. Carbonyls, we look at a C double bond O. Carboxyls, these are all here for you. Amino groups, these are going to be very important in proteins. Phosphate groups, we'll see these a lot in DNA, RNA. Okay. C double bond O with our carbonyl group and our hydroxyl groups and our carboxyl groups. These will be important in a lot of different compounds. You'll see these kind of all over the place as we talk about them. The reason these functional groups become so important, just to show you briefly, is estradiol, or an estrogen derivative, has this form at the top. So we've got 1, 2, 3, 4 carbon rings. We have the same 4 carbon rings in this lower structure. We've got an OH group. We've got a methyl group. Same. But then if we look at this end of the molecule on the left-hand side, for both, estrogen at the top, testosterone at the bottom. The only differences between these two molecules, the difference between whether or not you're a female lion or a male lion, or any female or male, the difference in production of this particular hormone is based on two functional groups, a methyl, and there's no methyl here, and a hydroxyl versus a double bonded O. So when we look at this kind of change, these are two very simple changes to this molecule, but it makes a huge difference in that functioning and eventually the characteristics that are expressed because of that molecule.